Good day once again. My name is Graphics. Today we'll be looking at mesh analysis. When you see a circuit and you are told to analyze it using mesh, the first thing you need to know is that you need to name each mesh. If you watch my previous video, I already told you what a mesh is and what a loop is. Now I will call this to be my mesh A, right, having current A. I'll call this to be my mesh B, having current B. So this is A and this is what? B. And I will assume I will take a clockwise direction and I'll also take a clockwise direction, right? Now you're taking clockwise direction here. Is that taking? Now because they are sharing a common boundary, you're going to assume the current that is coming down here is IA minus what? IB, right? So that means here we have IA and here we have IB. Is that okay? Now the next thing you do here is, let's name our loop. Our mesh should be A, B, C, D, E and F. So we'll take each mesh at a time. Now if this is negative, this is positive, this will be positive, this will be negative, this will be positive, this will be negative, this would be positive, this would be negative, this would be positive, and this will be what? Negative. So we'll consider mesh A, B, E, F, A. A, B, E, F, A. So this is what we are having. The mesh A, B, E, F, A. A, B, E, F, A is a closed loop that we started from A and will end at A. And the current flowing through AB, that is through resistor R1, is IA. Current flowing through BE, that is through resistor R2, is what? IA minus IB. So what you do is you analyze this. We know that when current flows through, the current moves from a low potential to high potential, so it will be positive. So we have 30. So we have 30 here, minus, when current moves through a resistor, there's a voltage drop. So I will know voltage is equals to what? IR. But the I moving through R1 here is what? IA. So we're having IA R1. So now when it moves from B to E, IA minus IB is one moving at this B to E here through R2. We have minus what? R2 into brackets what? IA minus what? IB. So there's no other resistor here, so equals to what? 0. Now what is my R1? My R1 is 4. So I have 30 minus 4IA minus R2 is what? 2. We have 2 into bracket IA minus IB equals to what? 0. So from here I'll be having 30 minus 4IA minus 2IA, I'm opening bracket, minus times minus will be plus, 2IB equals to what? 0. So if I collect like terms, this will be 30 minus this IA, so minus 4IA minus 2IA will give you minus 6IA plus 2IB equals to what? 0. Now if I take these two values to the other side, I'm going to be having 30 is equals to 6IA, because when minus cross to the other side of the equal sign become positive, minus 2IB, when plus cross to the other side become what? Negative. So I will term this my what? My equation 1. So that is when you consider this loop here, this mesh here. That's when you consider it. Now the next we want to consider now will be next we are considering here will be mesh BCDEB. So consider mesh BCDEB. So BCDEB will be having something like this. This is what we are having. So drawn out our mesh. So this will be BCDEB. So if you compare it with what we've had earlier, you recall that this is what I just drew out, and this is my 24 volts here. So let's proceed. So from here we'll start. Since we start from B here, so from B we're having moving from a high to a low, so there's a voltage drop here. So we're having minus IB R3 coming down, moving from a high potential to a low potential, will be minus 24. Then now we are moving against the current, because I'm moving in a clockwise manner and this current is coming down. So since they are colliding with each other, what happened? Instead of me writing a negative, I'm going to put a positive sign here, because of what? This is coinciding with what? This current coming down. So I'll be having plus R2 into bracket IA minus IB. So equals to what? 0. Now from here we know that my R2 is 2. So I'm having minus what? My R3 also is what? My R3 is 3. So I'm going to be having, what's my R3 is 3. So I'll be having minus 3IB minus 24 plus 2 into bracket IA minus IB equals to what? 0. So if I open the bracket here, I'll be having minus 3 IB minus 24 plus 2 times IA will give me 2IA, and 2 times IB will give you minus 2IB equals to 0. Now if I collect like terms, I have IB here, IB here. I'll be having minus 5IB minus 5IB plus 2IA equals to, I'll take this to the other side, become what? 24. When you take negative 24 to the other side of the equal sign, become 24. So I can rearrange this, since they are still in the same right hand side, left hand side. This will be 2IA minus 5IB is equals to what? 24. The sign will not change because it's still remaining at the same side, so you don't bother to change the sign. I'll only just move it anywhere 5 go to, minus will follow it. So this is my equation what? Equation 2. Now in doing that, now I'm going to combining equation 1 and 2. I'll be having my equation 1 is 6IA minus 2IB, well 6IA minus 2IB is equals to 30, and 2IA minus 5IB is equals to what? 24. So I just rewrite this first, followed by this. So this is what we're having. So this is equation 1, and this is equation 2. So we are going to solve this simultaneously, right? So the first thing we do, we use the quotient of IA and multiply everything in equation 1. So use the coefficient of IA in equation 1 and multiply equation 2, right? Also use the coefficient of IB of IA in equation 2 and multiply equation 1. So what I mean is this: you use 2 here to multiply everything here, and use 1 here, and use 6 here to multiply everything here. So this is what we're having. What I mean is, multiply this by what? By 2, and you multiply this by what? By 6. So if I do that, 2 times 6 will be having 12 IA minus 2 times 4 give you 4 IB equals to what? 60. 2 times 5 is 60, and 6 times 2 is 12 IA minus 6 times 5, that will be 30 IB is equals to what? 6 times 24 is what? So we're having 144. So from here, this will now be our equation 3 now, and this will be our equation 4. So now you are now going to, the next step is what? We are going to subtract equation 4 from 3. So we're subtracting, then this is the next step, and this will give us 12IA minus 12IA. 12IA minus 12IA. So minus 4IB minus that will give you plus 30IB equals to 60 minus 144. So this will now give us 12IA equates 12IA. Positive 12IA, negative 12IA, they equate each other. So minus 4IB plus 30IB, we'll be having 26IB equals to 60 minus 44. We are going to be having, so we're having 84. So my IB now, IB will be equals to 84 over what? Over 26. So 84 divided by 26 will be what? 3.230. So we're having 3.230 amperes. That is the current IB. Now, for we to get IA, you are going to substitute IB in equation 1 above. So where is my equation 1 above? This is my equation 1 here, and that is 6IA minus 2IB is equal to 30. So we have 6IA minus 2IB is equals to what? 30. So if you input your IB, you'll be having 6IA minus 2 into bracket 3.230 is equals to what? 30. So I'll replace my IB with 3.230. So from here, 6IA minus 2 times 3.2, we have 6.462. 6.462 equals to what? 30. So from here, 6IA equals to 30 plus 6.462, because when this come here become positive. So 6IA will now give me 36.462. So if you divide both sides by 6, my IA will now give me 36.462 all over 6. So 36.462 divided by 6, we're having 6.077 amperes, right? Amperes. So we have gotten IA. We know that our IA is giving us what? 6.077 amp, and IB is giving us what? 3.230 amperes. So now that means if you move here to the main question here, you discover that the current IA minus IB will be, our IA minus IB will be, what is the IA? 6.077 minus 3.230. So minus 3.230, and that will give me we'll be having 2.847 amperes. So that's the current come here will be what? 2.847. So we might be told to calculate for the voltage drop across each resistor. So this is what we'll be having. Now we know IA is 6.077 and IB is equals to 3.30, and we know IA minus IB is 2.847 when calculated. If we are told to calculate the voltage drop in each resistor here, so that means IA is flowing through RA. So I'll say, okay, the voltage drop across the V1 resistor is this, and the voltage drop across the V3 resistor, the R3 resistor is this, then the voltage drop across the R2 resistor is this, right? So what we'll do is we'll say that V1 is equals to what? IAR1. So that means the voltage drop across this. So my V1 here will now be, what is the IA? IA is 6.077 times 4. So my V1 here will now give me 6.08 times 4, 24.32, to have 24.32 volts. So this is the voltage drop across the R1 resistor. So similarly, if we want to know the voltage drop across the R2 resistor, it will be V2 is equals to what? I into brackets IA minus IB multiplied by what? R2, and the current that flows here is 2.847. So we'll be having 2.847 multiplied by R2. R2 is what? Is 2. So we are going to be having 2.847 times 2, so 2.85 approximately times 2, and we're having 5.7. So we have 5.7 volts. So that is the voltage drop across the V2 ohms. And we will be told also the voltage drop across R3 resistor. So the V3 will be equals to what? IB R3, because it's IB that is flowing through R3, so it's IB R3. IA is flowing through R1, so it's IA R1. IA minus IB flowing to R02 to be IA minus IB times R02. Those are the voltage drop. So in this case here now, V3 will be IB times R03. So my V3 here, what is the IB? IB is 3.230 times R03, which is what? 3. So we're going to be having 3.23 times 3, 9.69 volts, right? So these are the voltage drop here.